day everyone, I am Rolando A. Ilando, 2M26 section from Mindanao cluster. Application of derivatives and integrals, these are our topics for today. Derivatives and integrals are important tools in mathematics and real-life application. Derivatives are used to determine rates of change, optimizations, motion, and business analysis. Integrals used in finding areas, volumes, accumulated quantities, and many engineering applications. In this presentation, I will solve one application of problem-solving derivatives and one application problem involving integrals. In this problem, which is optimizing problem, a farmer wants to build a rectangular fence beside a river. Only 3 sides are fencing needs because the river serves as the 4th side. If the farmer has 100 meters of fencing, what dimensions will maximize the area? Okay, here's the step 1. Identify the given information. Let x or width, then y is equals of length. Since only 3 sides are fenced, we put it 2x plus y is equals to 100. So solve for y. Y is equals 100 minus 2x. And in step 2, we get or write the area of the formula, which is the area of a rectangle. So area is equals of x times y. Substitute the y equals of 100 minus 2x to area is equals of x times 100 minus 2x. Then the result is area is equals of 100x minus 2x squared. So we don't have any done yet, but we have other step 3 to differentiate the function. So the differentiate the function with respect to x. So which is we call it, and we write it dA is over dx is equals of 100 minus 4x. So where is the come from the 4x? So as you see, the square of this of the first area, which is the 2x squared, so which is the integral derivative of 2x, or is 2 times 2 is equals of 4x. So now it's set derivative equal to 0. To set the set the derivative to equal to 0 is equals to 100 minus 4x is equals to 0. So now we put 4x is equals of 100. So the result is x is equals to 25y, because 4x divided by 4 and 100 divided by 4 is equals of 25. So we cross out the 4 in the 4x. So how about we solve the y? So here's the step 4. Substitute the x into 25. So y is equals 100 minus 2 times 25. So the result is y is equals of 50. So the final answer of this problem, which is the dimensions that maximize the area, are width is equals of 25 meters and the length is 50 meters. So here's is, in this problem, derivatives were used to fix the maximum possible area. We first form an equation for the area, then differentiated it to locate a critical point. Okay, to setting the derivative equal to 0, we obtain the dimensions that maximize the area. So that is what we call. Now, here at the problem 2, in application of integrals, an area under the curve. So which is the problem is find the area under the curve. So as you see, the y is equals of x squared plus 2x, and from x equals to 0 to x is equals to 2. Now the step 1, write the integral. The area of formula is equals of area is the integral 2 over limits 0 is equals times x squared plus 2x dx. Now, the step 2 is integrate. Integrate each term. Now, the a is equals to x cubed over 3. So, which is which is the power, rather we put it to the division. Now, that we call x cubed over 3. So, plus x squared and 2 limit 0. So here are the step 3, apply the limits. Now the limits is substitute the x equals, now the result is 8 over 3 plus 4. So the substitute of x is equals to 0 to locate. Now the result is 0. So step 4, simplify. Now the area is equals of 8 over 3 plus 12 over 3. Area is equals to 20 over 3. So that is the final answer. So the area under the curve is 20 over 3 square units, which is in this problem integration was used to determine the area under a curve. We wrote the definite integral integrated the polynomial function and applied the upper and lower limits to obtain the final area. In conclusions, derivatives and integrals are powerful mathematical tools used in solving practical and real-life problems. Derivatives help us determine compute areas. Now, to volume the areas and the quantities, through these applications, we can better understanding the real-life situation in engineering, science, business, architecture, and everyday life of our situation or in this world. Now, that is all my presentation and tutorial for this moment. Thank you for listening.